Kia ora koutou. This is video 3 going through Mrs. Roberts' mini practice worksheet. I think these questions are actually easier than the ones that we had right at the end of video 2. And at the end of video 2, I rushed through how to do grouping on quite a hard quadratic. So for that, I recommend that you go and find my video on factorising by grouping. If you can't find it, send me an email and I'll point you in the direction and give you the URL for it. Okay, so in question 12, in these ones here, we've got to expand and simplify. And then to finish up, we've got a couple of what we call quadratic inequations. Okay, and these are a bit tricky if you don't draw a graph. So I'm going to pop some graphs in here. I want you focusing on these only if you're going really well with the rest of the topic. Okay, otherwise we can come back to them later on. Right, but the first 3 should be all good. So I'm trying to see what question we're up to. In here, I think this is question 12. So x minus 3 squared is equal to x minus 3 times x minus 3, which is x squared minus 3x minus 3x plus 9, right? So doing it like this, remember to take the negative sign with you, and then here, and then this one times this one. Or if you prefer, you can plonk it into our grid method that we had at the start, and you can do it like that. Either way, we should get x squared minus 6x plus 9. Okay, that's the first one done. Right, the next one is question 13. So 4ab times 7ab plus 2 plus 6b. Here we have to multiply everything inside here by 4ab. So we get 28a squared b squared plus 8ab plus 24ab squared, right? So in each case, I'm taking the 4ab and I'm multiplying it like this, right? And this is a good one to see with the grid method, right? So here's my 4ab, and here I've got 7ab plus 2 plus 6b, and we can just go bit by bit like that, right? But most of you won't need to do that by now. But the grid method is always a great method to come back to if you're having trouble. And this one here, 2x minus 3 times 3x plus 1. I'm going to do this the fast way, right? So 2x times 3x gives me 6x squared. Now 2x times 1 gives me plus 2x. Minus 3 times 3x gives me minus 9x. And lastly, negative 3 times positive 1 gives me minus 3. That gives me 6x squared minus 7x minus 3. But this one I am going to do with the grid method if I can get enough space. Let's see. Okay, 2x minus 3, 3x plus 1, 6x squared minus 9x plus 2x minus 3, and you can see that that matches up to what we've got in there. Okay, what's left? Right, so now we've got these 2 slightly trickier ones, and I'm just going to pull up my word solutions that I've done myself so that I don't go wrong. So just give me 1 sec. I'll just grab my other laptop who's got them on. Okay, so if we have to solve x squared plus 3x equals 0, let's think about how we do that one. Well, it's a quadratic, and in year 11, the only kind of thing we've got in our toolkit is to factorise. So we're going to have x times x plus 3, right? Look at the 2 terms. My common factor is x, so it sits here. So we have x equals 0 or x equals negative 3. So far, so good. So what this question is asking instead is, let's have all of the values when we get x squared plus 3x is negative. So we still want to factorise. And we can do this on a number line, but I actually think it's a harder way to go. But let's do our number line and look at what's happening. Our critical values are 0 and negative 3, right? They're the values that make this thing equal 0, and so things are going to happen with changing signs. So let's think about here, if we've got a number that is positive like if I'm up here on my number line, then I've got a positive times a positive, right? This will be positive and this will be positive. And so that's going to be positive and not 0. So this bit here, let me just get a nice red color. So this is bad, right? So up here is not part of the solution. Similarly, if we put in like a big negative number, like -10, and then in here we put in -10 plus 3, it'd be -7, that's going to be +70. So that is also bad. So the bit that we want is this bit here. So that's how you can do it on a number line if you've completely forgotten what we did with graphing parabolas last year. So here's just a tiny bit of like intro to where we're going later in the year. And I know Mr. Hawke and I have tried to do this a wee bit with you guys to link up the graphing, and I'm going to be doing more of that in the next week. So, you know, it is worth trying to follow this if you can. When we have a parabola, if we have the pattern y equals x times x plus 3, we're going to have a normal shaped parabola, and it's going to cross here. Whoops, wrong. Sorry, it's going to cross at -3. Hopefully there's no maths teachers watching. So my values that make it 0, which are my roots, are -3 and 0. And then we're going to draw a nice parabola here. And we know that's a bad parabola because of the new stylus. It's a very wonky, oh, that's terrible. Let me get rid of that. I'll try again. Okay, the parabola that we're drawing is one that looks like this. And we're going to have this situation here. So here's my set of axes. It goes through the point 0 and -3. So you can see that y, which is x times x plus 3, is negative for some of that graph, and it's this part of the graph here, the bit I'm doing in yellow, right? And you can see that that matches up to x values between -3 and 0. So in here, the answer is this. X is between -3 and 0, right? Or you could write that in words, and we can check that with a value. Now, the last question in here is similar, and we have to factorize again. It's this quadratic, and we want to know when is this strictly positive. So we start by factorizing, and it's a very easy factorize. So it's x minus 3, x minus 8. So my critical values, or my crossover values, are x equals 3 and 8. So let's put those on a number line, and then we can look at what's going on. So if we've got a big number up here, this time, suppose we have 10, then we'd have 10 take away 3 times 10 take away 8. So I'm testing values, right? And I'd have 7 times 2, which is 14. So that bit is looking all good. And what about when I have numbers down here? Well, let's try 0, because that's below 3. We'd have -3 times -8, which is positive 24. So this bit is looking good as well. So in this case, I have two regions. I have x less than 3 or x greater than 8. And now we're going to do that again with the graph. I suppose if I'd been thinking about graphing, I could have used GeoGebra to do this nicely. But here, we've got a value here, a root here at 3 and a root here at 8. So my parabola is going to look like this. Really have to get better at drawing those. But you can see that we want the points, we want that value to be positive. So it's all this bit here and this bit here. Okay, so that's how we get this answer, that x is less than 3 or x is greater than 8. Okay, thanks for watching. As I said, if you are just hanging on for dear life with all of the revision in the last 3 videos, then please don't spend ages doing these quadratic inequations until you've got all of the simplifying work sorted out first. So talk to me if that's you, and I can point you where to go with some of the simpler skills in the topic.